Hello and welcome to my presentation on why I developed the render farm RenderGate. But first of all, what even is rendering? Why do we need it? For this we have here as an example the latest Avatar film, The Way of Water, where basically 95% of it is CGI and every single second of this needed to be rendered. This can take up to several days for every second, which is a lot of time. So we would like that to be faster. So first about me, I started working with 3D animation since I was 11, which my parents supported in various ways with various projects. I worked with the 3D animation software Blender, which is free and open source, and is steadily growing to be one of the most powerful and professional softwares out there, in my opinion, and is currently also one of the most popular ones. I started working on this mostly on 3D animations in the construction industry. Here we can see an animation of the ABS Bahnhof Bern, for which we did an animation. Please ignore all the pink. It's unimportant. So yeah, we started working on various projects until finally we did an animation for the U-Bahn in Berlin, which took 200 hours just of pure render time. Luckily, we could split it up over multiple PCs, but it still took 3 whole days where we couldn't use any of our PCs basically at all. So we needed a solution. At the time, I started my apprenticeship at WebZüricch Consulting AG, which is mostly focused on cloud solutions for various things on AWS or Azure, which inspired me with the idea that why don't I just offload all this computation to the cloud? Of course, I checked various other solutions as well and checked competition, but in the end, I decided to develop my own render farm. So, why even is rendering so hard? Basically, to get a smooth video, we need to have 24 images displayed to us every single second. So for a 3-minute video, this would be 4,320 images in total. Each of these images needs to be generated in 3D animation, and for this we need to simulate how the light bounces off of objects, gets refracted through glass or water, or gets bounced around in fog. We need to simulate these light beams for every single pixel hundreds of times to get an actually smooth result. This can take for every image up to 10 or 20 minutes for a normal video. For more advanced animations like blockbuster films like Avatar, this can take from 60 minutes to days. But we are mostly focused on a bit of smaller projects. But still, for our 3-minute video with 10 minutes per image, this is still 30 days of pure computation on one PC. So yeah, let's make that faster. I first developed a prototype render farm based on AWS with 100 CPU machines, which allowed us to speed up our process 20 times. This was also cheaper than any of the other render farms at the market at the time. This solution was not very professional. It was a prototype, like I said. It was very complicated to use. You took like 5 different steps just to upload a file. I needed to check the render process manually in case anything went wrong. There was no detection if I forgot an image or any other texture. So for the video earlier, all those pink surfaces, all missing textures, I uploaded the file twice, still missed them. Quite a pain. Therefore, yeah, I needed to render often double because I missed images. Yeah. So, yeah, we decided we could improve on this and put it to market. So we decided to make the process more automated, made the settings changeable after uploading them, in case you needed to change anything. We warn you for forgotten textures because that saves you a lot. And we decided to add graphics card support because 20 times faster isn't fast enough. You can always go faster. So yeah, that's where our professional solution RenderGate comes into play. We of course added a website where you can easily set up all your processes. We added a pre-estimation so you always know beforehand how much it's exactly going to cost you and how long it's going to take you, and various other project management things. Yeah, currently our render farm has 300 CPU machines with which 3 customers can render simultaneously, and we have 100 GPU machines with which 5 customers can render simultaneously. What graphics card are we using? We are using NVIDIA A10Gs, which are roughly equivalent to an RTX 3080. So for our 10-minute per frame example, 3 minutes in total, this would take 720 machine hours on an RTX 3080 to render. With our render farm, we can reduce this from 30 days down to just 1.5, which is a very reasonable amount comparatively. Of course, this isn't for free. We charge at $1.20 per machine hour. So for in total, we have 720 hours of compute time over all of our 20 machines, resulting in $846 in total. Of course, you know beforehand, thanks to our pre-estimation, that it's going to cost that much. So yeah. Currently, we are mostly based on AWS infrastructure in Oregon and Ohio, which offered the best price performance for our solution. Now, finally, a comparison to other render farms. This is mostly a comparison of GPU performance because CPU performance isn't really all that relevant. Most times you'll be using GPUs for their faster computation compared to their relatively lower price per render hour. So yeah, a few of these render farms uh, to compare this, we could have just looked at the numbers that they publish on their various websites, but these numbers are generally hard to compare. They use units like dollar per gigahertz hour for the prices, which you can't really compare between different render farms because a gigahertz can mean for one CPU one thing and for another. So yeah. Instead, we actually took a benchmark file, the Cosmo Laundromat demo from the Blender website, and rendered 100 images of it on GPU on each of these render farms. A few of these render farms don't actually have GPUs, so they're excluded, and 2 of them stopped existing between starting the list and actually running the tests, so we'll also remove those. Also of note is Conductor Tech, which charged us $300 and didn't produce anything. So yeah, not that great, but it was probably misconfiguration. They are mostly targeted at large blockbuster productions where you can afford to have just one specialist manage your render farm, and it allows a lot more freedom. We are mostly focused on smaller teams where we manage most of the settings for you, so everything is easy to set up. If we remove those, we're left with 5 different render farms. The results are costs between $5 and 33 and times between 10 minutes and 2 hours. Very large gaps, so mostly we can recommend 2 of those. Garage Farm, which took 20 minutes and cost $10, and RenderGate, that's us, with 10 minutes and $5. Garage Farm offers over us a few more render farms and more established, of course. But they offer no pre-calculation, which we offer, and of course we are also half as expensive and twice as fast. So yeah, they also offer more options for render speeds at higher costs, but we mostly focused on the cheapest option since this is mostly a price comparison. So yeah. Finally, to get back to the beginning, Avatar 2, huge project. They even increased the frame rate from 24 frames per second to 48 to get even smoother water animations. But of course, this doubles the computation for the rendering again, which is a lot, especially since the frames take very long for this movie in the beginning even. Um, this is huge amounts of computing, so of course they offload it also to various clouds, especially they uh, basically rented a whole 3 AWS data centers in Australia just for rendering this one movie. So yeah, thanks for listening.